Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 34 from the Smith Organic Chemistry textbook. And so this problem is asking us to draw polymers given a set of monomers. And so the first set of monomers that we're given for A is one of the monomers has an amine on each side, and the other monomer has a carboxylic acid on each side. So this is obviously going to be a polyamide. This is going to be linked by amide linkages formed when each of the amines adds into each of the carboxylic acids to form an amide. And so we can go ahead and get started. And we'll start with an amide linkage. Oh, actually, here, let's do this. So there's our first amide. So this piece, oops, I drew that backwards. Apologize. Okay, so here we go. So this piece, what we've drawn so far, comes from the first monomer. And then now we're going to draw the second monomer. There we go. And actually, to be consistent, we'll end it right here. So this way, we're showing the polymer. This is a single subunit of the polymer. So it's each of the two monomers joined, and so that's a good place to end it, to be consistent, because otherwise we'd have to draw each subunit again to really be consistent. So when you go to show a polymer, you do want to be sure to show the polymer in entire increments. So this is what I've drawn, is one subunit, one monomer, and the other one. And so I wouldn't want to then just draw like another amine piece and not include the other carboxylic acid piece. It would be technically correct, but it wouldn't look great. So we'll cut it off there. So moving on to B, we're going to do the same thing. So from B, our first piece is this. Let's start here. So there's our first piece. And then our second piece is going to look like this. And then again, we'll stop it there because otherwise we'd have to draw a whole nother subunit. So that's B. C is going to look a little weird. It's going to look a little cramped. This would probably be an interesting polymer to deal with in real life. I would imagine it has quite a bit of strength to it because it's going to end up being so kinked. But so C is going to look like this. So there's the one subunit, one type of monomer. It will be linked to the other type of monomer, which is going to look like this. So that's C. And then for D, we have only a single monomer, and one end is an alcohol, and that alcohol is going to act as a nucleophile, and the other end is a carboxylic acid. So we're going to be forming ester linkages. So we'll start here. And so that's one subunit there. And I'll actually go ahead and draw a second subunit in this as well. So there we go. That's two. So for all the others, I just drew one. But since this is just a single monomer in this case, I drew two. Yeah, just so that you could see how they're linked together a little more apparently. And so that's the answer to chapter 31, problem number 34.